Bonsoir à toutes et à tous. Ce soir, on se retrouve à Bordeaux KT. Bon, pour ceux qui étaient déjà là à une des deux premières soirées, vous savez comment ça marche. Bordeaux KT, on est le user group de Bordeaux pour Kotlin. On existe depuis 2019, sauf qu'il y a eu le Covid et du coup, il ne s'est pas passé grand-chose. Et donc là, depuis environ 6 mois, on est de retour. Vous pouvez retrouver toutes nos informations sur nos liens. Donc principalement, vous avez le site web, vous avez la chaîne YouTube où il y aura la rediffusion des événements passés. Si vous ne voyez pas encore les rediffusions des événements passés, c'est qu'ils vont arriver. Ça prend un peu de temps. Vous avez l'adresse mail, si jamais vous avez envie de présenter des choses, présenter des sujets, ou si vous avez envie de sponsoriser l'événement, vous pouvez nous rejoindre à cette adresse-là. Et depuis récemment, une page LinkedIn où on annonce les nouveaux événements. Ce soir, on est sponsorisé par 4SH. Alors 4SH, vous connaissez peut-être. 4SH, donc on est une ESN, on fait du logiciel dans plein de domaines. On a des choses en rapport avec la douane, on a des choses en rapport avec l'assurance, on a des choses en rapport avec les voitures électriques. On a un peu de tout. 4SH aussi organise de formations. Je vous ai mis les dates de quelques formations qui arrivent bientôt, où il reste encore des places et qui pourraient être dans le sujet. On est aussi sponsorisé par JetBrains, JetBrains qui sont bien évidemment les créateurs de Kotlin. Ils nous offrent quelques avantages. On a par exemple des stickers, on a des petites choses comme ça. De temps en temps, on a des licences IntelliJ à offrir. Et de temps en temps, on a des speakers qui viennent pour nous, comme Anton qui présentera tout à l'heure. Pour les petits agendas pour les événements à venir, le 23 avril, il y a la prochaine soirée de Bordeaux JS. Ils vont parler de Forensic Analysis et ils vont parler de jeux musicaux multiplateformes avec React Native. Le 16 au 18 avril, on a Devox où il n'y a plus de places disponibles. Donc si vous avez déjà une place, tant mieux, sinon, dommage. Le mercredi 23 avril, je l'ai déjà dit, le mercredi 29 avril, il y a un Codelab Kotlin chez Sphere pour les développeurs Java pour qu'ils découvrent Kotlin. Ça peut vous intéresser. Et bien évidemment, du 21 au 23 mai, on a la Kotlin Conf à Copenhague. Il reste encore quelques places et le programme est en ligne. Donc si vous voulez y aller, il est encore temps. Quoi de neuf? Alors en temps normal, à chaque meet-up, dans cette section-là, je présente les nouveautés depuis le dernier meet-up. Là, il se trouve que le dernier meet-up, il était il y a à peu près un mois et il n'y a pas de nouvelle version qui est sortie depuis. Premièrement, et deuxièmement, on est ce soir pour voir une présentation de Anton sur tout ce qui est nouveau. Du coup, je ne vais pas spoiler sa présentation. Et du coup, je vais m'arrêter là et je vais laisser la parole à Anton Arhipov de JetBrains qui va nous présenter les nouveautés de Kotlin et ce qui nous arrive bientôt dans les prochaines versions.
So, my name is Anton. I come from JetBrains. I live in Tallinn. That's my home city there. If you ever have a chance to visit, don't go in winter. And maybe not worthy visiting in spring as well. It's still too cold. But summertime is pretty good. So, after the talk, if you have any questions to me or afterwards, I have my DMs open. So you can reach out to me on Twitter. No problem. I will try to answer everything I know. Or direct to people who know stuff. I generally don't know stuff. I know people. So Kotlin was announced in 2011. I happened to be in the same room when it was announced at JVM Language Summit, and I thought, oh, nice language. But we're gonna get Lambda soon in Java. And the irony was that in 9 years I joined JetBrains Kotlin team as a product manager, but switched into developer advocacy later. And it was announced as a general purpose alternative for Java, right? It wasn't even working for Android at that time. So if you tried running on Android, it wouldn't work. So the team had to do an extra effort to make it work actually. And then, well, Google happened, right? You all know that. How many of you are using Kotlin daily? Everybody? And are you using IntelliJ? Or Android Studio? No? No? So you are using Kotlin for the server side? Yeah. Or for data manipulation, whatever, right? Not Android? perfect. You are my people. I know nothing about Android generally. I haven't even built an application with that. So when I joined, Kotlin was already an established language, and my expectations were a little bit different, and the reality check was also different. So people were already very passionate about the language and what they want from that language. Generally, they missed some things in the language to be more powerful, more expressive, yada yada, right? So even when it was announced, there were a lot of questions about why not Scala, or why not Groovy, or can you bring this feature from Scala or that feature from Haskell, or do various stuff. But what is your favorite Kotlin feature today? Extension function. Functions in general, and then extension functions as a like concrete feature, right? Anything else? Like if you had to talk to your Java friend or a PHP friend or whatever friends you have, what is the most important feature of Kotlin? Sorry? Data classes? Well, 10 years ago, if you showed the data classes to a Java developer, that was like an easy sell. Like, boom, data classes, like they replace like this huge amount of code for Java classes. But today, Java has records. Meh. Why data classes? Like, what else?
Maybe safety.
Null safety? For me, it's the single most important feature in the language. It wasn't the first language to introduce the null safety. Actually, it was borrowed from another not so well-known language called Nice. You probably haven't heard of that, right? And today, if you look at other languages, Dart brings in null safety, C#, I don't know exactly how it's implemented, but also has null safety. Swift, right, also has something. So a lot of languages actually incorporate this feature. So it's often like funny to read the wars or like the arguments on Twitter or Reddit, people arguing which language is better, this language has that and that language has this. The thing is, it evolves over time. Languages evolve a little slower than AI tools today, but still at some point they kind of get their own trade-offs in language design, and you get those features that you anticipated, maybe just not in your lifetime. Okay, so if you look at some of the features that happened after 1.0, like multi-platform projects or coroutines or like inline value classes and so on, a lot of them were actually added after 1.0. And 1.0 happened in 2016, right? So the first release took 5 years. In fact, like 90% or 80% of the language features were ready on the first year. It's like 80-20% rule. You get 80% done in 20% time and so on. And after that, if we follow the evolution of Kotlin, what features were added, zoom out a little bit more, and by the time of 1.8, 1.9, there were a lot of small, really subtle features added in the language, mostly not like big ones, but rather making all the features coherent across different platforms, because multi-platform was in focus. And also adding those features was pretty hard, because when I joined in 2020, the release was scheduled for 14th of March, and it happened on 17th of August. And that's a clear indication of technical debt that happened with Kotlin. So the team was already aware of that they obviously experienced it firsthand. And that is why K2 happened. So it started in 2019, mostly on the paper first, and then the team was developing that behind the closed doors, and then we started rolling out the betas, for people to try, to test, and but it was very hard to get people to test it, because why? What's the benefit? It doesn't change the language. So why? Because, well, K1 was a prototype. So the very first prototype that was demoed at the announce of the language in 2011 was shipped as a product. Basically, it wasn't rewritten. Normally, you should write a prototype, throw it away, and write from scratch. But the team was keen on developing fast, and therefore, a lot of the decisions that were made on the design, like of the implementation, they allowed moving fast, because like initially Kotlin was even like a part of IntelliJ IDEA code base, was reusing the same APIs for the compiler, but it came at a cost. So, and when it was evolving, a lot of the language features, as language designers said, were appearing while they were working on one feature, and they saw that it kind of would play well with the other one if we had some other feature as well. Like, and some of the new language features were discovered along the design phases. Then the interaction with the IDE is another big thing, because, well, building the program from scratch, just compiling it, like the whole file, the whole package, the whole, I don't know, project, is completely different thing from when you are typing in the IDE and you want syntax highlighting to work, completions to work, feedback from the compiler should be faster, and so on. So the whole experience is different, although the final goal is to make correct code, right? And the third one is making the compilation faster, and that was the primary selling point for K2 for the users. Although when we released it, I don't want to say accidentally, but along the way, the team fixed quite a few issues without changing the language. So they kind of improved the internal engine of the compiler so that it could handle the cases that were could not be handled by the first version of the compiler. And the performance was in focus there. This is the compilation graph of IntelliJ monorepo repository. So it's not really 2x. It's about 40%, like depending on I don't know, on the time of the day and so on. But it's a great win. So monorepo is a big project. It's not just IntelliJ, it's all the IDEs together. And Android Studio reported 30% win for their code base. So that's great. And but what's the compiler? So we have the backend of the compiler, or many backends actually, for generating the platform specific code, either bytecode or native code, or maybe transpiling into JavaScript and so on. And a lot of and front end, and the front end was actually the K2 re-implementation. So the front end started to use the staged approach, first parsing, then creating a special data structure that we called intermediate representation for the front end, FIR. And but the essence of it is that some of the language constructs are desugared into some intermediate form, which kind of looks like this on the right, but in the program, of course, it's a structure. It's a data structure, kind of like a tree, but with metadata. And when the parser is actually parsing your program, it rewrites all those interesting statements on the left into something that you can see on the right. So if conditions are transformed into whens, the for loop is transformed into the iterator loop. The pair is like destructuring, or in this case, it's a pair and destructuring. That's interesting. And using the component function. So if you compile this code and decompile it back, decompile it from bytecode into Java code, you will see kind of those statements in there. But the effect of this is that because we got this new data structure with metadata, then we could implement the analysis engine that could track how the data, like how the variables is used, basically tracking the data flow inside the program, how what type is like a variable has, is it eligible for the operations, and so on. So this is not, it's a little bit synthetic in here. You probably wouldn't write this kind of code in the real life, right? Passing in a mutable list and then mutating something, you probably would do something differently. But this is just a demonstration in here. So we get a mutable list as a parameter, and you want to mutate one element inside. And what we are doing here, we are just adding one. And this is a legit code. It would work in the first version of the compiler. That's all good. But on the right-hand side of the expression, we have a long variable and the integer literal type. Depending on the practicality of the language, this might be an invalid situation. So for instance, if you are using a system-level programming language like Rust, this would be like a no-go, probably, or it needs safety, right? So like system-level safety. But for the application-level programming language, it's just impractical to forbid that. So it's a legit situation. But if we do an equivalent statement right there, plus a sign, then Kotlin 1.0, Kotlin 1.x basically wouldn't handle that. And thanks to this desugaring in K2, we have now a statement like this that is perfectly working, right? So we obviously had those bugs registered in utrack, and we knew that someday we would fix them, but then the whole thing was fixed by just the other approach to the compiler design, to this desugaring phase. Another a bit more complicated use case that wasn't working in K1, there is more, of course, there's like many of them. Just for the demonstration here, we have the use case basically with the same mutable list, but with nullable box variable or the parameter, and it's just desugared into a little bit different form. Still works automatically. Great. But I think those were like the side effects from my point of view. For the language designers, no, it's not a side effect. It's a real work. But I think one feature that got the new life in Kotlin now is the smartcasts. So you know what smartcasts are, right? So this thing, right? We check for the type, and then in the next line we can use animal without casting it. Any of you have Java background? Yeah. So you know what you have to write in Java to get it working, right? But this is like a simple case, and it just didn't work with variables, because variables do not carry the meta information, the type information for the compiler to be analyzed on the next statement. So in Kotlin 1.x it didn't work, and now with this front-end intermediate representation, we have the ability to actually check that and do smartcasts. So it works. But this is like the simplest example you can think of. What if we look at something more complicated like this? So as you can see, there are two smartcasts, right? What is happening when? First of all, like we have this conditional variable with expression on the right-hand side, and then we have card withholder match there to invoke a lambda, and then the smartcast is happening there inside. So first of all, we check for the card, right? And the smartcast is happening after that. So if that's successful, then we get there on the right-hand side, because otherwise it's a short circuit. And the other one, obviously, after the null check in this function. And now the question to you, it's interesting. Like I asked the same question yesterday in Paris, and a lot of Kotlin developers are there. Do you know why is it even possible to call is null or empty without a safe call? You know, of course. Like I know that you know, but any of you? Ivan, tell it.
It's because of contracts in the is null or empty declaration?
No.
No?
No, you're one step ahead. Like you're answering my next question. Why is it possible to call is null or empty without a safe call? Well,
You can have an extension function on a nullable.
right.
value.
That was the answer, right? Okay, on the nullable, exactly. So there's char sequence, is null or empty, and there is a contract, as Ivan said, right? And what is the contract? The contract is sort of a declaration of an effect that this execution will have an effect, and we can declare that as a contract, saying that if it returns true, or if it returns false, sorry, because it's not null, not null or empty, is null or empty. Okay, so if it is not null or empty, then it will return false, and it means that it implies that this receiver is not null, right? We can just use it afterwards, and that's a great information for the compiler, because we can use that in multiple places to help the compiler and help the users of our API as well. We can actually apply this trick in many places and help our, like if you are building a library, for instance, then the users of our library will get the help using that meta information from the compiler, making less mistakes. And generally, making less mistakes means that the language is safer. And in my opinion, it's a great thing, right? If you're just using the language and it just doesn't allow you to make mistakes, whatever code you write, is it ugly? This is secondary, if it's beautiful or ugly. But if it doesn't let you to make mistakes, then, well, it's the great value. So I have another example of this, like a toy example. Basically the same thing, right? We have, but just not for null safety demonstration. We have a simple hierarchy, an animal, and then a dog, and then the dog can bark, right? And then we are using this hierarchy as like the super type is a parameter, and then there is a check if the animal is husky, a dog, then it can bark. And there is a smart cast happening right inside. And if we go and check the implementation, there is a contract. It doesn't check for a null now, but it says that if it returns true, then it means that husky or this receiver is of type dog. Cool. So after this invocation, we don't have to do the cast anymore, right? And any check. And there is a good example of like libraries that you probably use. Do you use Kotest or do you use JUnit? JUnit, right? So in JUnit, when you are writing tests, if let's say you have a function that can return fun, let's say a string, whatever, but this string is nullable, then in somewhere in the test, let's say we have a fun test, we call this foo function, and sorry for that, and then we want to check if this function, if the value is not null or not, right? And usually in JUnit you do something like assert null or assert not null. And if we do it like this, and we need something else to be done here with this variable, like foo length, for instance, then JUnit doesn't have those contracts, but Kotest does. It's the same function, like visibly the same function, but it declares the contract, and therefore with JUnit I would have the compilation error still here. I would have to do the safe call, but with cotest, you see, it just works with the smart casts using the same approach, using contracts, right? Cool. Did you just learn something new? Nice. So it's not time wasted. Cool. So what's next for Kotlin? Are you following the news when Kotlin goes out? Do you read the release notes, like what's new, watching the videos and so on? Not really. Subscribe to YouTube channel, please. Okay. Perfect. So for Kotlin, there are many things happening, and because now, after 2.0, the compiler allows the designers team and the compiler team to work more like conveniently, faster, safer. And in 2.1, actually, we added, not really released, but let's say that we added guards expressions for pattern matching without binding. Because in Java you have pattern matching with binding. You declare a variable name in a pattern, and the variable is then used. In Kotlin we don't have that. And we actually had a nice live stream about all the new features we added in 2.1, along with multi-dollar interpolation, non-local break and continue, and so on. And they were released as beta state, and in 2.2 those things are going to be moved into stable, seemingly. There are no blockers, and but there are some other interesting features being added in 2.2. By the way, 2.2 is coming in May. I don't know if it's before Kotlin Conf or after. I hope I will not get a new t-shirt with multiple dates. But there is more interesting stuff coming, like name-based destructuring, reach errors. They are scheduled for 2.4, meaning in a year, in experimental state. So it's going to take time, but at least we see that big features started to be, are now on the table again for the team. And there are some forward-looking stuff, like effect system capabilities, basically extending the use of contracts even more. What I showed was basically what we had for the standard library, and the contracts are not really used in the application code normally. Collection literals. This is something Mikhail asked me to ask you, what your opinion on this thing. Let's look at that. Immutability is a really big topic, and we probably won't dive into that, but there is a big research and design going on around immutability, or improving or even making it more strict in the language. Today, like val is preferred over var, but that's a very simple, teeny use case. There is more you can do in the language. We probably won't dive today, but I really encourage you, if you go to Kotlin Conf, there will be a talk about that really in depth. Let's talk about context parameters, just briefly, that are coming in beta. So there are multiple use cases. I want to talk about my favorite one, the DSLs. So DSLs are not really a language feature, right? If you go and read in the documentation, do you know how it's called? Well, type-safe builders, right? But there is one mention of the DSL, but normally if you search how to build DSLs in Kotlin, you probably won't find the documentation page for that query. So we call them type-safe builders, and here's a very toy example of a builder. What's it doing? Like, we have a class with name and birthday, and then there is a function that takes functional literal with receiver as a parameter, so that we could build a library for our colleagues who want to build client instances, and then our colleagues would use it this way. We have like build client and then a block of code and a nice syntax, almost a nice syntax. It's nice because you have trailing lambda and then assignment to properties, but then there is an ugly code to your Java API for creating a date. Can we do better? We probably could, but what's the solution? Could be an extension function to an integer so that you could write something like this, right? 10th of March 2000. You see any problems there? I mean, it's right in front of you. The problem is right there. We can write, or we can use this function outside of the scope of the builder. So it's basically a global extension function. I like extension functions too. That's one of my favorite features, but it's a problem for many people, for many projects. If you are polluting the namespace, the global namespace of a type that is available everywhere. So we want to constrain or scope this function somehow, and context parameters can actually help here. This way, we can annotate this new extension function to say that it should only be visible within the context of the client builder object. And that client builder object, like the context itself, is provided by the library. It's visible inside the library. The client code doesn't know about that, right? But then how would the user of our library be using this, and how they would be able to constrain like the scope of this function? We can actually use the same annotation for the parameter type and say that whatever is happening within the block of code, or like to execute this block of code, you need this context, and then the library is responsible for providing this context with the with function, right? So if we, as a library author, you decide to change the implementation of the date library that is used inside as a transitive dependency, it means you don't really expose that into the user's call sites, into our user's code, and you are free to do so. Otherwise, it would be very hard to migrate for the users if you impose the requirement for the transitive dependency from your library. So how does it help us? Because we now declared the function is requiring the context, and the library is providing the context inside the implementation without the visible requirement on the user side. This will be, the latter call will be the compilation error, because it's happening outside of the context, and the context is only inside the block where we are building the client. So I think it's a nice use case, nice solution. You can argue that, well, probably builders are not so great just by the nature, and you probably could just use the constructors instead, or the function, just normal invocation of a function. But the reality is that inside the builder you can write imperative code, right? That's a big difference. So last year at KotlinConf we had this talk. It's only 13 minutes. If you want to learn more about context parameters and the use cases, Anastasia was actually talking about that, and there was 3 main use cases for context parameters. The community of library developers are actually waiting for that badly. So what else is coming to 2.2? The check return value. You probably haven't heard about that, really. It's a small feature, but it actually does very useful thing. And it's coming into the 2 in a slightly limited scope, not at full, but we're gonna see some valuable things there. So what does it do? Consider you have 2 functions, fetch user that can return a nullable user, null value, and then we can charge the user for a vast amount of money, and then the charge function actually returns a transaction ID. So how it would look like in the application code, we fetch the user, we get an instance of the user, and then we call the charge function via the save call operator, and like with some parameter, and it looks good, right? any problems that you could spot here. Actually, normally in the IDE, you would maybe, if you have this inspection, a relevant inspection enabled, there would be a warning. What could be that warning? Sorry? Yeah, we don't use the return value. And well, the ID inspection is a useful one, but it's not enforced. And you know, you can switch it off. As a library author, you probably have a very good opinion why this value should be used and checked somehow, right? So what we can do, if we annotate the return value, or we provide some contract that the return value should be used and checked, then you would end up with this kind of code, basically. And the cool part is that you get an exhaustive when. This feature currently, I actually removed some details that make this example relevant. As you can see, there is transaction ID, but there is also transaction error. This is a small reference to the next feature that we have in mind, the error types, or we call them rich errors, or you might have heard about them as union types for errors. So what if the charge method returned not just the transaction ID, but also the error types? And in this case, the when expression becomes like an exhaustive check. You have to check for all the things. If it's success, if it's an error of one kind, or if it's an error of the other kind, and so on. All right. So and when expression is very useful here in this context as well. We're gonna check the return errors just in a second. But here is another example. What do you think will happen here? The answer is very simple, nothing. Because there is no return, nothing is happening, right? The on each is a non-terminal operation, and you won't see the result. But if we annotate or like use the check return value in here, that would be a compilation problem, basically. I don't know if they will make it a warning or an error, but this will be reported from the compiler. So basically, we kind of move a tool from the IDE, an optional IDE inspection, move into the compiler, move into the language, and give this tool into the hands of libraries developers, right? You as a library developer will be able to require your users to check for the return values, and that's a good thing. Again, it moves us further in this goal to create a language that allows less mistakes on a practical level. So in Tutor 2, it's going to be annotated, like this annotation will be used in the standard library and with opt-in. So if you start using the standard library just as is, it won't be, you know, exposed yet. But if you want to check how well the compiler can catch errors, this kind of errors for you, then opt-in is going to help you. And then on the next steps, I don't know if it's 2.2, 2.3, maybe 2.4, there is a plan to move on with the libraries as well, Kotlin X libraries, of course, and then expose this annotation as part of public API so that you could use it in your application code. Name-based destructuring. Do you like destructuring at all? Is it convenient? Have you ever had this problem that you can run into errors when using destructuring? Yeah? How did it happen?
There was a data class, and you could do destructuring. So you can do destructuring on the data class to get the different fields.
Yeah.
And one day someone reordered two of the fields and the word of the same type. And so everything else would still compile, but the behavior, everything else where destructuring was used was different.
Exactly. So that's the simplest way to get this error, but in practice I haven't seen this happening myself. I'm just wondering if people actually stumble upon that you made this, you wrote this nice code with the structuring, and some other colleague came and changed the first name and last name order in the declaration side. Or like, what are the steps for the API or data class maybe was changed somehow over time to get this kind of error. So potentially it's a problem, and you never know what the logical outcome would be from the program. Maybe you will be charged 1 million instead of €1 because of this error. That's a potentially big problem, right? So what is happening there? Just a very simple explanation. So we have data class and name and title. We can assign do this destructuring assignment, right? And as you can see, the title is on the first place, and the name is in the second one, and well, we are not matching on the names. This is exactly the situation that could have happened like in real life. But here is another proposed syntax for name-based destructuring. So it's not positional now. We can write in any position the names of the new properties or new fields, new variables, and then they will be assigned correctly. But they have to match on the name. So if they don't match on the name, actually they do. Interesting. I actually copied this from language designer's slides, so maybe they have to be in correct position as well. But if they don't match on the name, well, there will be a compilation error. And this would work actually for normal classes as well. That's a cool thing, because then you don't need to use the component functions, right? The component 1, component 2, component 3, and so on. And it's going to be experimental in 2.4. So reach errors is the cool thing. We are like briefly flashed the idea, but basically what you need to think, how you need to think of those, they are not exceptions, they are values, but they are values with types. And therefore we are getting this new interesting syntax like error class something or error object something. And but how does it help us? So if we have functions like this and we use nulls as errors, that's a perfectly legit code today in Kotlin. What could be the problem here? What do you think? Getting immutable? Oh, yes, right, correct. So if we have nulls as errors, like generally, like the good thing about them is that they allow us to write concise code because of extra operators we have in the language, like the save call and Elvis operator and so on. And it's still imperative, like simple baby code. Everybody can read and understand that. So there are some good things, and even Roman actually wrote this blog that now is your friend, embrace it. It's not an issue. It's just a matter of building a boundary between nullable world and our null safe world, and then everything will be okay. But the problem is exactly what you said. Like if you just return a null, what kind of null it is? Like if you have multiple reasons for a failure, is it parsing error or network error or I don't know, something else? And the file error. So we need a clear way to indicate what kind of error happened. And today, well, people do this kind of interesting things. They introduce sealed hierarchies because they can. Like it's a good modeling. Why not? And then they kind of create hierarchies and assign the meaning to those hierarchies, to the types. And this is like normal process, right? The clarity. But there are some problems. Well, if you have a huge hierarchy of those sealed classes, it's kind of hard to extend it properly. It is kind of verbose, and well, nesting is I don't know. I think it's a matter of taste. Some people don't have problems with nesting, but our language designers are very keen on getting rid of nesting everywhere they can. There is another way, the result, using the result class type from the standard library. It is kind of better extendable in a better way than the sealed hierarchies, but it's still kind of verbose compared to the initial implementation. Well, functional operators, again, it's a matter of taste. Some people like that. And well, in this situation here, we kind of we have a problem with exhaustive when, because we have an else at the very end, and some developers, some projects really try to avoid using else branch in when expressions to keep the exhaustiveness check. So if we are back into this original example that we had initially, and try to introduce the new tool, the error types. So how would it look like? The signatures are kind of the same, but then using this logical OR kind of operator, we can also declare that the function can return a real type or an error. And that works only this way, so that you have one real return type and one or many, or zero or many error types, just to indicate that the method can fail in various reasons, right? So you cannot use two types. It's not a general purpose union type as people would react to this, and this is why actually I think they didn't tell me. I think this is why they are now calling it rich errors, not union types for errors, because it sets wrong expectations. But in this case, we still keep the original code. It looks pretty much the same. We still get the type safety, because the compiler will force us to handle the error kind or error type. And if we rewrite with the new feature in mind, if we rewrite this code with this new feature in mind, we switch to this exhaustive when. We now check all the return types exhaustively, and it's pretty concise. And as you can see, we don't have problem with extensibility of this thing. Yesterday, one person actually asked, like, can you abuse this feature? Or do we afraid that this feature could be abused? And I actually started thinking, and what is the situation that allow you abusing this language feature? What do you think?
Someone may be declaring error types to use as classical types. To write boolean types.
That's an interesting idea. I haven't thought about that, but they don't have. I'm not sure if they can carry any values. That's one thing. Another thing, like if you, what does it mean, like abusing it? Trying to use a very long declaration that would, like have one error, second error, third, 10th, and so on. Yes, it's possible, but then you're kind of abusing yourself, right? Well, unless there is a good reason. If you're implementing a library that for one operation can throw 1 million different errors, then you just don't have any other choice, kind of. Right. So the new hierarchy, the new type hierarchy that will look for Kotlin will be the any with error at the very top. So if you remember, we had only any at that place, but the errors will be in the different hierarchy from the other types. So they are kind of values, but they are also types. That's an interesting change. So and there is obvious question: what about exceptions? Because have you tried Swift? No. In Swift, like I generally like checked exceptions in Java, like as a notion, like that it exists. But the implementation really sucks because people generally don't know how to use them properly without huge nesting. A try with resources is kind of helping with that, but not much. And in Kotlin, we got rid of those checked exceptions for two reasons. First of all, people hate them. Secondly, they don't really play well with lambdas. But if you look at Swift, for instance, they still have a way to declare that a method can throw any kind of exception or error. And it forces you, like enforcing you to check or to handle this exception. So the enforcement from the compiler that something can throw is a very useful thing, especially if you work with I/O, networking, protocols, something like that. And that's why those who write this kind of application in Java, they don't really like that Kotlin doesn't have checked exceptions. So in Swift, if a method can throw, you can have two ways of handling it. Either just normal try catch, or a command that is prepended into before the method. That is a keyword in Swift. Try foo, right? The foo method invocation. And this try command binds the result of that invocation, like if the method is returning something, into an optional value. So it kind of is, if we had a special keyword in Kotlin, and instead of, I don't know, string, if the method fails, it would automatically catch that and put it into a nullable string, for instance. Right? But we have another approach to that. We have errors now, and but we need to deal with the exceptions somehow, so that it would be convenient to translate into errors. So there would be a standard library function that you can just use in your program and map your exception into an error. It's not really an enforcement from the compiler. It's just for your convenience. I would like to see, I don't know, if I'm using, I don't know, buffer stream from Java library and it throws I/O exception, I would like to have this indication in Kotlin that I have to account for that. Currently, I just have to know to use this function and map into an error. So that's currently, I don't know, like we'll see how it works out. But again, there will be a talk at KotlinConf, reach errors. There will be more details, of course. I'm just scratching the surface. So I encourage you to visit that or watch the recording afterwards. Collection literals, let's make it, how much time do you have?
Go about 15 to 20 minutes
Oh.
more, if you want.
No, let's keep it shorter. But this one is important because I want your opinion. Collection literals is this keep that we have currently, and it's being actively discussed. The essence of it is that today, if to declare a list of values, you would write this code. Tomorrow, if this feature is implemented, you will get this kind of code, right? What do you think about this? Is it great or is it bad? Or if it's bad, why? If it's great, why?
Well, for my part, I feel that this is not so necessary, as in Java, it's a huge lack that you have to instantiate a list first, then delete its elements. Well, there are
In Java, you would write kind of the same line as the first one, just the capital letter dot off and
yeah,
get the same.
yeah, but I feel that list of is quite sufficient, and I don't see
The value of, okay.
new syntax, basically.
Okay, so for you, the reaction is meh.
Yeah.
Besides, we kind of lose the information and the difference between list of and mutable list of.
Okay,
Sometimes we can
right.
use it, and if you just in the second version you can lag the information.
So if you had to declare an array or a mutable list of, like this, you would do that this way. And it kind of is similar. What is interesting here is it kind of is a, you can think of it as a type inference. It really is not type inference, but for you as a user, on the right hand side of the assignment, right, they are both the same, but on the left hand side you have a type anyway, right? So you kind of can save some characters, kind of, right? But this is like a very simple and isolated use case. Why would you need to know what's on the right hand side if you already know that on the left hand side? I mean, the type is already there, right? Yeah. So let me show another example here. So we might have a method that accepts some collection, and then today you would write it like this. You invoke the function, and then you explicitly invoke the function there. But we already know that the function actually accepts the collection, and we could write it this way without an extra function written on the side. I personally was thinking, okay, do I want to know what type of collection will be created if I just write the code? That you see, there's like some people really want that. Some people don't care. I'm just writing code. It's good enough. Why would I have to know, as a user who types this line, why would I have to know the type of the underlying collection? What do you think? I don't have an answer. I'm just very curious. Yeah.
As mostly a library developer, I really like that feature actually, because that means when creating DSLs, we'll be able to expose, like for example, if you go into Gradle build files, you get a lot of list of, etc. Well, Gradle is even more complex because it uses mutable lists, but you're not allowed to mutate them, so you have to create new lists each time, and well, that's
Exactly.
Gradle. But providing a DSL where people can just put multiple elements and don't have to think about exactly the type of collection I'm going to use afterwards, I think that's going to be beneficial. The downside I see is I've read the keep, and the keep is quite complex, and that decision brings a lot of edge cases in many ways. For example, around compatibility with Java, because when you call a function from Java, you don't know if it's a mutable list or a read-only list. And so then, from what I understand from the keep, the compiler will, if you use a literal when calling a function from Java that accepts a list, it will always use a read-only non-mutable list. And like that could be surprising, I guess, maybe.
Well, for Java developers, it shouldn't be surprising because they don't have the distinction between read-only collection and mutable collection anyway. And it's pretty often the case. It's exactly what Kotlin is solving compared to Java, having those separate interfaces. That in Java, it can easily be that you receive a list and you think you can add an element there, but you can't actually do anything with that. So you get an error at runtime, not at the compilation time even. So yeah, but I just wanted to hear some of your comments. Actually, a good comment about the DSLs. I kind of forgot about that. I didn't write the DSLs for a long time. But if you have an opinion, if you like it and you have a reason, if you don't like it and you have also a reason to add something, then you're welcome to the keep discussion. There are active people arguing what's best and how it could be implemented. I don't have a strong opinion, that's why I'm not commenting, but maybe you do. So welcome. So with that, let's quickly look at something that doesn't exist. It's a science fiction, basically. I will repeat, that doesn't exist. So remember this use case with DSLs that we solved with context parameters, where we scoped a function, and it kind of is perfect now, our perfect safe DSL. But what if we don't assign a value somewhere in the middle? Can the compiler help us with that somehow? So one of the things that the effect system capabilities could do for Kotlin on the compiler level is to be able to describe a contract. I'm using an existing syntax right now for a non-existing feature that would kind of mimic what it's doing, but it's not real. I'm repeating, it's not real. So what I'm trying to express here is that the init block would have an assignment to an name property at least once. So if you are able to describe this contract this way somehow, and the compiler would understand that and then check what's inside the braces in the block, we get two interesting features thanks to this single approach. First, well, obviously it will be a compilation problem if we don't assign something there. But also, while you're typing this kind of code, let's say you're writing build client and opening a brace, the IDE could actually check that, well, there are some requirements in that block and they have to be fulfilled, and then the code could be generated. And imagine like 10 properties, like a live template in the IDE. Basically, it could be just very convenient for typing, right? This is just an idea. It doesn't exist like in any keep anywhere, but I see that the contracts are getting more extensions. Now we discussed that with Mikhail, and he said this would be an interesting direction to go to make it even safer. Again, it's mostly for the library developers, right? Not for the application code, because it's useful exactly for this kind of things.
So in client properties could be val now.
This is another aspect of it. You see, there are a lot of complications. Currently, if you are doing something with builders, they are mutable. They are usually vars. Now the question is, can we make them mutable but only once? And it's a big topic for immutability that I want to skip right now because we won't have time. But again, there will be a talk about that at KotlinConf, a full 1 hour talk on all the details, and immutability is spanning not only the builders, of course, but a lot of interesting other things that are happening with Java platform in the name of Project Valhalla. So Kotlin wants to be compatible with that as well in the future. So immutability is a big topic. So what do we have at the very end? We have the new compiler that allows the team to move faster. We have some interesting new features on the table, already even shipped in the 2.1. And then we are building more stronger abstractions and on the type level, on the library, and just in the language features. A lot of them will actually let's say go hand in hand. Let's say something that ensures the compiler checks, and then if you're like in some places, it will cause, as a side effect, it will cause an emergence of a new syntax or new language constructs as well. So Kotlin will start moving faster. With this, thank you for coming on this beautiful evening. I don't know, you could drink wine outside instead of listening to me, but you choose to come here. So if you have questions to me, my DMs are open, and I have some demo projects on my GitHub recently, adding too many of them thanks to all kind of AI tools. And if you need the slides, I will publish them later when I have a final version. I'm still iterating on those for Devox France next week. At the speaker deck, you can find them. Thank you.